processes for pharmaceuticals, vaccines, and biologicals. Without further ado, Victor, the floor is yours if you are ready. Thank you all.
Thank you, Dr. Dong, for the introduction. Let me put up this presentation. Is the sound correct?
Yes, this is correct.
Okay, and we see the full screen.
Yes, we can see the full screen, correct.
Okay, thank you very much for that. Okay, welcome everybody. Thank you for inviting me to present this topic. First of all, before we go to the outline, I would like to just mention that all the modules and sessions are interrelated, and we encourage all the participants to complement each other because they are aiming at the same objective of producing a sustained compliant environment. So that's something important. Today we're going to see an overview and points to consider on cell banking upstream and downstream processes, identify the applicable GMP regulations and requirements, identify risks and deviations, examples of critical process parameters and critical quality attributes, and some case studies. It is important also to mention that a life cycle approach is always encouraged, as you were able to see, you have been able to see during all the sessions, and this is not the exception. Life cycle approach is the main expectations in manufacturing, including, of course, vaccines. Also, the idea is for your organizations to expand your knowledge, and not only expand it, but also to manage it in the best way possible in order to build your own capacity. This presentation will be mainly from a GMP perspective, sharing the experience gained through several pre-qualification audits. The objective is that maybe we can help all of you to prevent typical problems that eventually impact the product. So going to the presentation, as we mentioned, first of all, before we discuss and talk about upstream process and downstream process, we need to stop a little bit in cell banking. This is important because the nature and the variability of biologicals are very related to how we protect our cells, which are going to be the basis for the finished product. So this is the first concept I would like to share, that the quality of the finished product, in this case, vaccines or other biologicals, start in the cell banking. This is just to show that we have different cell banks depending on the product that you will produce. That's why this drawing is separating the animal cell substrates from the microbes. This is basically, if you have the microbe in the right, you would have cell bankings related to bacterial vaccines or maybe viral vaccines. If you had viral vaccines, you would need, which is indicated in the left, which is the animal cells, in order to propagate the virus. So this is basically the main frame that you would have in cell banking. So in terms of cell banking, this is a very highly audited topic. This is the first message I would like to convey to all of you. So I encourage you to pay close attention to this topic because it has happened that many deviations are related to this topic. First of all, the storage and handling conditions of cells or seeds banks is important. Basically, a lot is focusing to the access that should be controlled and restricted, and all the records maintained, including records of location, identity, and inventory of individual containers. When I'm talking about containers, I'm talking about, for example, cryovials, where the cells are stored, and removed containers should not be returned to stock. So the administration of the cell banking is something highly important, highly relevant, and heavily scrutinized during the audits. The number of generations expressed as passages or doublings between the seed lot or cell bank and the finished product should be defined and should be set into a maximum. That should be consistent, of course, with the market authorization dossier and should not be exceeded. This is very, very critical because any violation or excess in the passages would alter or possibly alter the genetic characteristics of the cells. And that might not be even detected immediately by the testing. So it's very important to have this under control. Of course, quarantine and release procedures for master and working cell banks should be followed. This is something important because it also resembles any other pharmaceutical product. So for cell banking, even with the challenges of storing, even for example in liquid nitrogen, we need to have the quarantine and reject also sectors and areas, even in an ultra freezer or in a liquid nitrogen tank. MCB, we're going to talk about MCB, which is master cell bank, and WCB, which is working cell bank, need to be stored in different separate locations to assure backup of cells. This is basically not strictly a GMP requirement, but it's something that is critical because it is important for the companies to assure providing the product a long time. So that's also a WHO concern. So the different locations are important in terms to have a contingency plan in case one of the locations have a problem that would affect or destroy the cells. Also, reliable records of the composition and source of the culture media used for the preparation of the cell banks should be maintained. Okay, going into some aspects, for example, establishing and handling the master cell banks and working cell banks should be performed under conditions which are demonstrably appropriate. This is a GMP requirement. It just tells you or requires that. So we need to interpret this, and one way that we suggest is that you check this guidance document, this WHO the guidance document, which has been mentioned in a couple of sessions before, which is environmental monitoring of clean rooms in vaccine manufacturing facilities, points to consider for manufacturers of human vaccines from 2012. So this is important because sometimes some doubts are raised, and in this case, you would find, this is taken from that document, that production of master and working seeds are recommended to be performed under UDAF, which is unidirectional airflow, remember, or class 2 biosafety cabinet in class C. So this is a typical requirement. Of course, you can have organizations that have higher classification, meaning even handling class B, but this would be a minimum. And there's a note, which is, I believe it's important. It says, due to the increased risk of contamination of seeds by adventitious agents derived from operators or the environment, in addition to the use of unidirectional airflow or biosafety cabinet, increased personnel protection equipment and procedures should be employed. The use of surrounding areas of class C or higher is recommended for open manipulation of seeds. And so this is important because usually we have a situation of open manipulation in these initial phases. Each storage container should be adequately sealed, clearly labeled, and kept at an appropriate temperature. This is important in terms of traceability. So the manner that we label, the type of label that we use, for example, which should be adequate for very low temperatures and maybe some humidity, is important. Even the printing of that usually should be on a computer-based printing, should be legible. So all the requirements for data integrity are here present. And also the temperature. The temperature is something critical, is the main requirement in this sense. So all the technology related to, for example, if it is liquid nitrogen tank, has to be there, and the maintenance and the replenishment of the nitrogen is usually or could be a problem for the companies. So this is one point to consider, very important. A stock inventory should be kept. The storage temperature should be recorded continuously, and where applicable, the liquid nitrogen level should be monitored. I would say always to monitor the nitrogen, liquid nitrogen level, and the temperature recording. Very important in terms of alarms and how those alarms are managed, and how are those alarms managed when out of working hours. This is also important. This is just a cell bank flowchart just to show the complexity that this could have. Here we are showing from left to right, we're showing the bacterial strains that would all have the master seed lot and the working seed lot. We use the term seed in the case of bacterial banks. We might have, for recombinant proteins and vaccines, we might have a recombinant E strain. For example, it could be Pichia pastoris or Saccharomyces used, which are genetically modified. And in that case, we would also have a master cell bank and a working cell bank. In the case of virus, also we would have the master virus seed and the working virus seed. And we could have host cells also, that also we would have, suppose it could be mammalian cells, like CHO cells, Chinese hamster ovary cells, that we could have, we should have the master whole cell bank and the